In this video, I want to demonstrate how Excel can be used to estimate a multiple regression model. Over here, I have simulated a sample drawn from a model which I know the parameters of because I set them. So I set up these parameters for a model, made some assumptions about the distribution of the various variables in the model, and then randomly generated some values down here that I could use as a simulated sample drawn from this population model. You'll be asked to do something like this simulation in the week 7 quiz, so it might be worthwhile you looking at the formulas in here and thinking about how these numbers would have been derived. But for our purposes, I'm just going to assume that we have values, observations on two explanatory variables, x2 and x3, and we also are going to use these observations on a y variable, the dependent variable. Over here, I've generated some descriptive statistics using the data analysis tool. And what I want to do now is actually estimate the regression model using this sample data set. So to do that, I'm going to select data up here and then data analysis. As we have previously, I'm then going to select regression. Now there's very little that changes when you're estimating a regression model using this regression tool. You need to select the y values, which are here. I have 50 y values there. One difference from what we've seen previously is that we now have two different explanatory variables, but this just requires me to highlight those two sets of explanatory variables. Previously we would have just had one set. In making my selections, I didn't choose the headings, so I won't need to tick this. I'm going to override the standard confidence interval and say I want Excel to tell me 90% confidence intervals for the regression parameters. Then I need to tell Excel where to put the output. I'm going to get it to do that in the same worksheet, just starting in cell I-23. And in this demonstration, I'm not going to look at any of these extra output options. So, having done that, I'll hit OK, and there we have it. Excel has produced or estimated the regression model. It's using the least squares estimators to estimate this model. We don't actually see those things happening, but the results of using those least squares formulas are the estimates that we see down here. And these are probably the most important thing that we're interested in when we run a regression analysis. So this is producing an estimate for the multiple regression model. What is the estimated model? It's that y is equal to 1979 take 4.8 times x2 take 2.77-ish times x3. And when I say x2 and x3, I'm thinking of their names up here, xi2, xi3. So we have a model that an estimated or a fitted regression line, which is y is equal to 1979 take 4.8 times x2 take 2.8 times x3. So that's our fitted regression line. Now that is only an estimate. In fact, up here you can see the parameters that I was using to generate this simulated sample, but you can see that the parameters are fairly close to the estimates that were generated from this sample. These are estimates. We don't expect that any given estimate will be exactly equal to the population parameter. we know that there's going to be sampling variation, which we'll see these fluctuating. This standard error is actually an estimate of the standard deviation of the sampling distribution for this estimator, the intercept. And similarly, this is the estimated standard deviation for this estimator, or the estimator, which produced this estimate. What else are we interested in here? Well, another parameter of the model is the variance of the errors, and that is an estimate of the variance of the errors. In fact, in my model that I set up, the population parameter for this was actually 10,000. So our estimate is in the right ballpark, but again, not exactly equal to what the population parameter was. You won't frequently talk about the variance. Normally you'll speak about the standard error, which is this one up here. This is the square root of that number down there, and it is an estimate of the standard deviation of the error term. And so one thing that you can see here is that anytime you see this word standard error down here, it means that it's an estimated standard deviation. In this case, it's the estimated standard deviation of the regression coefficients, or their estimators. And up here, the standard deviation is for the error term in the model. What else is of interest in here? Well, probably the one other quite important piece of information is the R-square. This statistic tells us what proportion of the variation in the dependent variable y can be jointly explained by variation in the explanatory variables, in our case x2 and x3. And this statistic is telling us that the model has quite good explanatory power. Almost 69% of the variation in y can be explained by variation in x2 and x3. Just looking at a few other features of this regression output. Here is some information relating to a hypothesis test. Well, in fact, there are 3 hypothesis tests. One about this regression coefficient. So the hypothesis test underneath here has a null hypothesis that beta 1, the intercept, is equal to 0. That's the test statistic for that test. And it's actually a two-tailed test. The alternative hypothesis is that the beta is not equal to 0, and this is the p-value of this test statistic for a two-tailed test. These ones down here, well, this is for a hypothesis test that this beta coefficient is equal to 0. This one is for a null hypothesis that the beta 3 is equal to 0, and it's a two-tailed test with the p-value for the test being this one here. It looks like, in this case, all our regression coefficients appear to be significant. The p-values are all very low. Like that negative thing there is saying that this is 5.23 times 10 to the power of negative 42. So there's about 41 zeros sitting in front of this after a decimal place. So very, very low value. And very low values of p-values are typically associated with a null hypothesis being rejected, which in this case would mean that there's strong evidence that the beta coefficients that we're testing individually are different, significantly different from 0. There are also some confidence intervals here being generated for those regression coefficients or parameters. So we've got a 95% confidence interval, which Excel will always produce, and then I asked it to give me a 90% confidence interval as well. Just to conclude, below the output that I've just produced is a copy of that output, but here I wanted to highlight some of the relationships between the particular pieces of information. The cells that are highlighted in yellow are ones that are just pure data. There's no formulas in those cells, so I've just taken the information exactly as Excel delivered it to me out of the regression analysis. But in every other cell, if you were to look at it, there's a formula embedded which shows how that number can be calculated by referring to one or more of the shaded figures. And it might be useful for you to have a look at the relationships between these items. Double click on any cell and it'll show you how that particular number is being calculated. Just down here I've put in a check row. This is a good practice when you're using Excel. Here I've got the raw output from Excel, and down here I've got little bits and pieces of the raw output from Excel, but then various formulas that I've added myself. And I wanted to make sure that the formulas I've added were giving me the same results as the raw output up here. And to do that, I've put these check cells where I basically just check that the sum of the numbers in the raw output in a particular column is equal to the sum of the numbers in my adjusted output. And if those two sums are equal, then I can be pretty confident that my numbers down here are the same as the raw numbers up here. And I haven't made any errors when I was typing formulas. If you look across that row, all the values are equal to 0, so I'm pretty confident that what I'm showing you here in terms of formulas is not going to be misleading you. Okay, so that was a quick introduction to estimating a multiple regression model using Excel.